So if I want to take the derivative of this, the derivative means make a function that finds slopes at any point of this parabola. What I do is I apply this formula. So it's x to the second, and it's 2. So if I want to find f prime x, which is the derivative, the slope generating function, I take the 2 and I bring it out front and I drop this by 1. See? I bring the bring it out front, and then drop the power by 1. So what that ends up looking like would be the 2 comes in front, the x stays the same, and then 2 minus 1 is 1, which you don't need the 1, you could just call it 2x. So this is your derivative function for x squared. The usefulness of this function, well, comes to this next part. What is the slope of the function at x equals 1? So it's the same function, so we know that is our derivative. So if I want the slope at 1, what I want is, what is f prime of 1? Meaning, what is the slope or derivative at 1? And if I plug 1 into this function, it'll tell me how steep this graph is when x is 1. So if we simply use the function 2 times x, and again, 1 is the number we're plugging in for x, we get 2 times 1 is 2. So what that is saying is the slope of x squared at 1 is 2. And that slope is the instantaneous rate of change. AKA, if you drew a graph, the tangent line would have a slope of 2 at 1 for the function x squared. So if we want to find the derivative of this, well, when you have multiple monomials that have powers, what you do, you still apply this formula for derivatives just one by one, each individually. So it's actually, what you get is f prime x, which is the derivative of f. You just do each one by one. So the derivative of that would be, well, the 3, leave the 5 out front. Actually, let's just do it that way. And then the 3 goes in front and drops the power by 1. All right? Then this one would be a minus 7. And you might want to think of this as a 1 right here. So you put the 1, put the x, drop 1, so it'd be a 0. This is kind of a little bit weird how I'm writing it, but it'll make sense. Here, you could write an x to the 0. I know it's going to confuse you a little bit, but x to the 0 is really 1. So I have a plus 2, okay, times 0 to the x. Remember, you put 0 in the front, and you drop 0 by 1, negative 1. All right, so what do I get when I simplify all this big mess? Well, let's see. F prime x is equal to, well, we have 5 times 3 is 13x squared. Okay, that's doable. Sorry, 15x squared. I think I said that wrong. Now, we have here, okay, what's anything to the 0? That's 1. And 1 times 1 is 1. So isn't this equal to 1? So negative 7 times 1 is just negative 7. All right? 0 times anything is 0, so that's just 0. 2 times 0 is 0. So really, this whole thing is just 0. So I'm not going to put a plus 0 at the end of this. So this right here is my final answer. And what I hope you see over time is this. If you have a simple x, you don't need to put the 1 there. What happens is when you have a simple x, this just becomes a constant. When you have a constant, take the derivative, it disappears and becomes a 0 because of this, what's happening right there. It will come with time. The more you do them, the more you see it, and it just, you get used to it. So let's find the slope of this function at 3. Well, since we have the derivative function, we can now find the slope at 3. So what we're going to do here is we're going to find f prime of 3. So we're going to put a little blanks here. Our derivative is 15x squared minus 7. And what we're plugging in is 3. So we're taking the derivative function. We're going to plug in 3 repeatedly. So this right here becomes a 9. So what we have here is 15 times 9 minus 7. And then 15 times 9, well, that is equal to 135, and we still have the minus 7. Okay, and 135 minus 7 is 128. Now 128 means the slope of this function at 3 is 128, a rise of 128 and over 1. Extremely steep, but that is how steep it is. And if you know anything about cubics, they are pretty steep. So that is the slope at 3 for this function. First we had to find the derivative. And the derivative gives us slopes at any point. Any number you plug in, you could find the slope of any number you want. That is the power of the derivative. This could find slopes anywhere you want. You just got to plug a number for x, and you know the slope at that specific point.